You know, in just about every factory, mill, and plant, there's this unsung hero working away in the background. It's not glamorous, not at all, but it's one of the most critical pieces of equipment for keeping people safe and the air clean. We're talking about the industrial baghouse, and we're going to break down what it is and why it's so important.
So, what is a baghouse? The absolute best way to think about it is like a giant, super-powered vacuum cleaner. Seriously. But instead of sucking up dust bunnies from under your couch, it's capturing everything from heavy cement dust to crazy explosive grain dust. It's what keeps the air inside a facility safe to breathe and stops all that nasty stuff from getting outside.
Okay, so how does this giant vacuum actually pull it off? Well, the trick is to think of it less like a simple filter and more like a high-performance engine, an engine that runs on air. It's all about managing airflow and pressure to get the job done. At its heart, the process is actually pretty straightforward. It boils down to a simple 5-step loop. First, all the dusty, dirty air gets pulled into the collector. Then, it's forced through these huge fabric filter bags, and all the dust gets trapped on the outside of them. What comes out the other side? Clean air. Finally, all that collected dust gets knocked off the bags and falls down into a hopper to be hauled away. Simple, but man is it effective. Now, when I say bags, please don't picture the tote bag you take to the grocery store. No, these things are high-tech, highly engineered filters. Depending on what they're for, like handling super high temperatures in a metal foundry or dealing with sticky wood dust, these bags are made from really specialized stuff. We're talking felted materials, woven fiberglass, even advanced fibers like aramid. Each one is custom built for a specific kind of dust. All right, so we know how it works, but how do you know if it's working well? You gotta check its vital signs, right? And for a baghouse, there is one number that is more important than all the others: differential pressure. The best way to think about it is like the system's blood pressure. It tells you pretty much everything you need to know about its health. So let me ask you this. If you could only watch one single number on that whole control panel, which one would it be? You got it. It's the differential pressure, which you'll usually see written as delta P or delta P. So what is this number really? Differential pressure is just the difference in air pressure between the dirty side of the bags and the clean side. See, as dust builds up, it gets a lot harder for air to push through. That resistance causes the pressure difference to go up. So that number, which we measure in inches of water column, is a direct, real-time indicator of exactly how clogged up your filters are.
And that brings us to the operational sweet spot. For most of these systems, you want to see that number hovering somewhere between 3 and 6 inches. If it's too low, it actually means you're not filtering very well, because that initial cake of dust hasn't formed yet. But if it gets too high, the whole system is basically choking. The fan has to work way harder, which wastes a ton of energy, and you're not really moving air or capturing dust like you should be.
Obviously, that dust can't just build up on the bags forever. To keep that differential pressure in the sweet spot, the baghouse has to have a way to clean itself off. Think of it like a power-up in a video game, a way to reset and get back to peak performance. And there are a few different ways to do it. First up, you've got the old-school method, shaker cleaning. And yeah, it's pretty much exactly what it sounds like. The whole system has to shut down, and then the bags are mechanically shaken, and I mean shaken hard, to knock all that dust loose. One expert described it perfectly. They shake like they're dancing at a honky-tonk. It works, but all that violent movement is really tough on the filters over time.
A much gentler approach is called reverse air cleaning. In this case, a low-pressure flow of clean air is sent backward through the bags, causing them to gently collapse inward. That subtle little flex is just enough to make the dust cake break off and fall into the hopper. It's way easier on the filter bags, but it can sometimes struggle with dust that's really sticky.
And then you have the hot rod of baghouses, the pulse jet. This is the one you see most often these days. It uses these really short, powerful blasts of high-pressure compressed air that shoot down into the bags. This creates a shock wave that just blasts the dust right off the outside. It's so fast and powerful that the system can keep running while it cleans. The only downside? It needs a constant supply of expensive compressed air to work.
Okay, so we've got the how, but what about the why? Why is this all so incredibly critical? Let's do a quick lightning round and look at a few industries to see the real-world dangers that these baghouses are built to stop. Let's start with the grain industry. The fine dust from flour or corn is highly combustible. Over in cement plants, you've got this heavy, abrasive dust that will literally wear out machinery. In foundries, they're dealing with tiny metal fumes that are a major respiratory hazard.
Woodworking, more combustible dust. And in food manufacturing, believe it or not, something as simple as sugar or spice dust can create a serious explosion risk.
And we should not downplay that risk. The formula for a catastrophic dust explosion is terrifyingly simple. All you need is dust floating in the air, plus oxygen, plus an ignition source, which could be just a tiny spark, all inside a confined space. Put them together, and boom, a baghouse's main job is to remove that very first ingredient, the dust in the air.
So this hero system is protecting people and equipment from some really serious stuff. But a hero is only as strong as its health, you know? The effectiveness of any baghouse, I don't care how well it's designed, comes down to one thing: good, consistent maintenance.
So what's that look like? Well, it starts with checking that delta P every single day. It means doing regular inspections, looking for tears or leaks in the bags. If you have a pulse jet, you got to make sure the valves and solenoids are all firing right. And you got to use your ears. That hissing sound, that's a compressed air leak, and it's costing you money. The whole key is to be proactive and replace your filters before they fail, because one unplanned shutdown can cost you tens of thousands of dollars.
I absolutely love this quote from the source material because it is so true. That rising pressure, that hissing sound, a little puff of dust coming out of the exhaust stack, those aren't random problems. Your baghouse is talking to you. It's telling you exactly what's wrong. You just have to be willing to listen.
And really, that brings us to the final thought here. This unsung hero is working 24/7, protecting your people, your product, and your entire facility. So the real question you have to ask yourself is your plant's hero getting the attention it truly deserves?